Good afternoon. My name is Sebastian Diaz, and I will be talking about the three Newton's laws of motion. Let's begin. Isaac Newton was an English mathematician, physicist, astronomer, theologian, and author who is widely recognized as one of the most influential scientists of all time and as a key figure of the scientific revolution. Newton's three laws of motion describe the motion of massive bodies and how they interact. While Newton's laws may seem obvious to us today, more than 3 centuries ago they were considered revolutionary. The first law of Newton states that objects at rest remain at rest and objects in motion remains in motion in a straight line unless acted upon by an unbalanced force. I would use myself as an example. Alright, I am currently at rest. This is normally taken as the definition of inertia, meaning that if the velocity of the object is zero, then the object remains at rest. Because there is no net force acting on an object in equilibrium, then from Newton's first law of motion, an object at rest will stay at rest. Now, what happens if I keep the object? Not surprisingly, the object moves. This is because I apply an unbalanced force to myself. Forces that cause a change in motion of objects are called unbalanced forces. Therefore, the object stopped being at rest because I kicked it. Now, for the second law of Newton, force equals mass times acceleration. But what does that even mean? Newton's second law says that when a constant force acts on a massive body, it causes it to accelerate. In the simplest case, a force applied to an object at rest causes it to accelerate in the direction of the force. For example, alright, here's a soda can. If I apply more force to an object, guess what? The object will accelerate. If the mass of the object increases, then a greater force will be needed, therefore a greater acceleration. Newton's third law states that for every action, force in parentheses, in nature there is an equal and opposite reaction. For example, this is me on a swing. Right now, I'm gonna start doing an action. Now, whenever I am going forward, I'm having a reaction that is equal and opposite, in this case, going backwards. The action and the reaction are simultaneous, and it doesn't matter which is called the action and which is called reaction. Both forces are part of a single interaction, and neither forces exist without the other. Now, this will conclude the three laws of motion according to Newton. Thank you for watching.